Hey, how you doing? A quick recap for the VSEPR for experimental chemistry. One of the things you're going to want to make sure that you do if you're doing this VSEPR work is you're going to be looking at the Lewis structure for a particular molecule. You're going to be counting what we call the electron domains around the central atom. And then if there are 4 electron domains, you also want to look at how many unshared pairs are around that center atom. So real quick, if your central atom only has a single pair of electrons, whether it's in a bond or not coming off of it, it's going to be linear and 180 degrees. If that central atom has 2 electron domains, in other words, a bond there and a bond there to another atom, that would be 180 degrees linear. If your central atom has 3 electron domains, it's going to be trigonal planar. It's going to be like a triangle if that were laying flat on the ground, 120 degrees. If there are 4 electron domains and each of them is a chemical bond, it would be tetrahedral with a bond angle of 109.47. I have a hard time trying to draw this, but this looks like a pyramid with an antenna sticking up. If, however, one of these isn't a bond, it's an unshared pair of electrons, then the shape would be trigonal pyramidal. That would literally look like a pyramid, and it would be a bond angle of a little bit less than 109.47. If you had 2 of them that were unshared, so 4 total, a bond there, an unshared pair, 4 domains, but 2 of them are unshared, that would be a bent molecule, again with a bond angle of less than 109.47. So if we take a look at a few of these molecules, for example, H2. If you pick one of these to be the center atom, let's say this H right there, there's one domain, one bond, one pair of electrons coming off of it. That bond shape would be, or that molecule shape would be linear. So it literally would be an atom here and an atom here, 180 degrees apart. If you had something like BeH2, the beryllium has a pair of electrons there and a pair of electrons there, 2 domains. 2 domains, again, 180 degrees linear. That molecule would have a hydrogen, a beryllium, and a hydrogen in a straight line. If you had something like AlH3, notice there are 3 domains, a hydrogen there, a hydrogen there, a hydrogen there. 3 domains would be trigonal planar. Very straightforward. Let's look at this one here, this NH3. You have 1, 2, 3, 4 domains, but one of the domains is an unshared pair of electrons. So we would go to 4 domains, 1 unshared pair, that would be trigonal pyramidal with a bond angle of less than 109.47. You can see some other ones, SCl2. 1, 2, 3, 4 domains, but 2 of them are unshared pairs, that would be bent. Or you could see CH4, there's 4 of them, but there's no unshared pairs, that would be tetrahedral. The last thing I would mention is sometimes a molecule you'll see might have double bonds. For example, CO2, carbon dioxide. If you see a double bond or a triple bond, treat it like a single domain. So that would be 1 domain, 1 domain. So that carbon has 2 electron domains around it. So that would be linear, 2 domains. So I hope that helped. In terms of the assignment that we had given you to do, it was really looking in that virtual program, putting in some molecules that you have the Lewis structure for, and seeing if they come out as you predicted them to be. Feel free to use any of these and see if they come out as predicted in terms of the shape and the bond angles that you see. For what we need to know, they may give you a bond angle that's less than 109.47, and if they do, they might give you the real bond angle. All we need to know is if it's 109.47 or less than 109.47. You may also see some molecules that are a little bit different where maybe there's an unshared pair right there, so there's 3 domains. That's actually bent less than 120. So there's a few in there, but these are the key ones that you need to know. I hope this helps.